Good evening, dear students. Yes. So in the last class, we have started with organic chemistry, right? So we have discussed the basics of organic chemistry, right? So today we are going to continue the same. So we have solved some questions in the previous class. Okay, so we will start with the next questions. So yes, so I have ended my uh, class here. Okay, in the last class. So let us continue. So in this chapter, what we are discussing, we are discussing the basics, right? We are discussing the basics and the principle which are involved in the organic chemistry, right? So everything basics has been told here. Okay. So let us start. Let us start with the today's questions. Okay. So we have to start from this. So carbocation as an intermediate is likely to be formed in the reaction. What do you mean by carbocation? What do you mean by carbocation? Carbon having a positive charge, right? Carbon having a positive charge. So this is a example. So this, if I give you an example, so this is an example of a carbocation. Okay, here you can see the carbon is having what? A positive charge. So this is called as a carbocation. Okay, carbocation. So the carbon is having a positive charge. Okay, means what? It is less this what? It is electron deficient. Okay, it is this carbon is electron deficient. Okay, such species they are called as what? Carbocation. Okay, so the electron deficient species they are called as carbocation. So this carbocation it is formed as an intermediate. What do you mean by intermediate? An intermediate product. Okay, in the middle. Suppose a reaction is going A to B. Okay, so in between A to B, okay, there at half time. Suppose for a reaction A to B, it requires 1 hour. To convert A to B, it requires 1 hour. So at 30 minutes, okay, at 30 minutes, what will happen? Half of the A has converted into B, right? And half of the B is having what is to be still converted, right? So here, what is happening here? Yes. So what we are discussing, so that intermediate point or the middle, okay, so that is called as the intermediate, okay, in between the reactants and products. It is called as what? Intermediate. So carbocation as an intermediate is likely to be formed in the reaction. So in which of the reaction carbocation is formed as an intermediate, as an in-between product? So these are the four options. A, propene when it is reacted with Cl2 in the presence of UV light to give you 2-chloropropane. B, acetone plus HCN, that is hydrogen cyanide in the presence of OH minus ions, okay, to give you acetocyanohydrine. Then C option, ethyl bromide plus aqueous NaOH, KOH, okay, that is potassium hydroxide. When you heat this particular mixture, you get ethyl alcohol. And D, hexane, when you react it with anhydrous AlCl3, okay, or HCl, okay, what you're going to get? You're going to get 2-methyl pentane. Okay, so in which of this following, you are going to get an intermediate as carbocation, they have asked. Yes, try answering this. Try answering. So in which of the reaction is the carbocation formed, students? Okay, Hema has answered it as D. In which of the following carbocation is formed? Okay, propene means what? You are doing what? Alkene is there. Okay, on alkene you are doing chlorination, right? You are doing free radical mechanism to give you chloropropane. Okay, so in this there is no formation of carbocation intermediate. Then you have what? You have a acetone, a ketone, and you are adding hydrogen cyanide. So this is a addition reaction. Okay, this is a addition reaction. So here also there is no intermediate product formed. carbocation as an intermediate product. Then ethyl bromide plus aqueous OH. Okay, so this is a substitution reaction. Okay, so what is happening? Your Br minus, okay, CH3, CH2 Br plus KOH. Okay, so your replaceable this what you're attacking, this is OH. So what you are going to get? CH3, CH2, OH. So your Br is been replaced by OH minus ion. So here also there is no formation of intermediate. Hexane. What is hexane? Carbon system with what? Carbon system with 6. Right. So this is a hexane molecule. So hexane molecule, when you treat it with anhydrous AlCl3, aluminium chloride, in the presence of HCl, okay, it undergoes isomerization. Okay, what do you mean by isomerization? The number of molecular formula remains the same. There will be just change in the structure. Okay, so what you are going to get? You are going to get CH3, CH2, CH2, CH, CH3 and CH3. So here what you can see, you are going to get a 2-methyl pentane. Okay, 2-methyl pentane. So this is 1, 2, 3, 4 and 5. So 2-methyl pentane. So in this product, okay, so here when you are forming hexane to your 2-methyl pentane, in this reaction it involves the formation of carbocation. Okay, it involves the formation of carbocation. Either the Cl, your nucleophile is okay. So what will happen here? Either it will the attack takes place here or here. So by seeing the stability, okay, so which is carbocation is more stable. So when we see the carbocation stability, tertiary is more stable than secondary, and then is your primary. So this is the stability of the carbocation. So when you see the carbocation stability, so your secondary will be more stable. So because of that, so your answer is third one. Okay, fine. Okay, so let us go for the next one. IUPAC name of the following compound. So this is a compound given. So you have to tell the IUPAC name of this compound. Try to answer. So if you don't know, so CH3, okay, CH, C, C, double bond, H, then CH, H and Br, then here it is H. Okay. So what is the name of this compound? Can anybody tell me what is the IUPAC name of this compound? Yes, students, try. What is the IUPAC name? You should try. First, this is what you have to select the longest chain, right? You have to select the longest chain. Yes. So if I see, so here 1, 2, 3, 4, right? So I will start it from here. So 1, 2, 3 and 4. So this is the longest chain. Okay. So this is bute. Okay. So bute, because 4 carbon atoms are there. Then first what you have to see the substituent. So which is the substituent? Your Br. So at one position you have 1 bromo. Then what you have? Then you have at second position, you have your double bond. So it is bute. Okay, at second position, you have butene. So it is option number 1 bromo, 2 butene. Yes, so it is option number A. Are you getting the same? Are you getting the same? So it is option number A. Understood? So first select the longest chain, then go for the substituents. Okay, so here only one substituent is there. So the substituent should get the least number. Then the double bond. Okay, it is what position it is having? Second position. So it is 1 bromo bute. So at second position you have double bond. So it is a alkene, right? So we represent as ENE. So our suffix will be ENE. So answer number A is the answer. Okay, option number A is the answer. I hope it is clear. Okay, let us go for the next one. In which of the following homolytic bond fission takes place? In which of the following homolytic bond fission takes place? So before going to this, okay, what do you mean by homolytic fission? And there is one more type of this homolytic fission and heterolytic fission. Okay, now when a breaking of bond takes place, when you are breaking a bond, so there are two types of bond cleavage taking place. One is the homolytic cleavage, another is the heterolytic cleavage. Homolytic cleavage means what? So it is between the same atoms. Okay, it is between the same atom. So it in between the same atom, okay, the bond is shared. So how this bond is shared? By equal number of electrons. So hydrogen is having one electron. So this hydrogen is having one electron. So equal number of electrons are shared. Okay. Now when this bond has to be broken, it will be broken into two half. Okay, it will be broken into two half. So each hydrogen will give one electron. Okay, hydrogen will get one electron. So this is called as homolytic fission, or it is homolytic cleavage. Okay, so equal number of electrons are distributed. Similarly, if I take this chlorine, okay, so the pair of electron is shared between this and it forms a bond. So when a homolytic cleavage takes place, okay, so equal number of electrons are distributed to each atom. Okay, so this is homolytic. Now, what do you mean by heterolytic fission? Okay, what do you mean by heterolytic fission? So, heterolytic fission is formed, or it takes place between two different atoms. Okay, it takes place between two different atoms. Suppose I have taken here HCl. Okay, between HCl. Now, between hydrogen and chlorine. Okay, so these are two different atoms. Can anybody tell me which is a highly electronegative atom? Yes, which is the highly electronegative atom between these two? It is the chlorine, right? Chlorine is the highly electronegative atom. So chlorine has the tendency to attract the electron pair towards itself. Okay, chlorine has the tendency to attract the electron pair towards itself. So as a result, what will happen? What will happen? The When this bond is broken, okay, chlorine will take its pair of electron with it, and hydrogen will be left with no electron. So this undergoes a heterolytic fission. Okay, it undergoes a heterolytic fission or heterolytic cleavage. So unequal sharing of electrons. Okay, unequal sharing of electrons. So electrons are not shared equally. Okay, so here what is happening? Due to the chlorine as highly electronegative atom, it will tend to pull the electron towards itself. So what will happen when the bond is broken? Chlorine will take its pair of electron. So negative charge means what? It is rich in electron. Okay, negative charge means it is rich in electron, and positive charge means what? It is electron deficient. It is electron deficient. Okay, so hydrogen is electron deficient. It is left with no electron, and chlorine is left with extra electron. Okay, it is rich in electron. So this is about homolytic and heterolytic cleavage. I hope it is clear. So they have asked, so there are four options. So they have asked, in which of the following reaction the homolytic bond fission takes place? A, free radical chlorination of methane. B, alkaline hydrolysis of ethyl chloride. C, addition of HBr to double bond. D, nitration of benzene. Okay, Hema has answered it as A. What about others? Why others are not answering? Please answer. Okay, Tejaswani has also answered it as A. So in which of the following the homolytic cleavage takes place? Okay. Now it is what? Yes, it is option number A. Now when the free radical mechanism takes place, how the free radical mechanism takes place? Yes, it takes place okay, between in the presence of a halogen and your light. Okay, so what will happen? Your chlorine molecule, any halogen, whatever you have taken, okay, so that it will homolytically okay, and then at each step your free radical is added up. So free radical formation, it takes place how? It takes place due to homolytic fission. Yes, so option number A is the correct answer. Very good. Okay, I hope it is clear. So alkaline hydrolysis of ethyl chloride. alkaline hydrolysis of ethyl alkaline hydrolysis. So what is happening here? Alkaline hydrolysis means your Cl will be replaced by OH minus. So here there is no bond fission takes place. What is happening? Your Cl is replacing the OH. Okay, your Cl will be replaced by OH. So there is no breaking of bond, that is free radical homolytic cleavage taking place. Then addition of HBr to double bond. So when you are adding the HBr, okay, so here also there is no homolytic fission taking place. So this is also not a example. Then nitration of benzene. Nitration of benzene is what? It is a substitution reaction, nucleophilic substitution reaction. So this is also electrophilic substitution reaction, sorry. So nitration of benzene. So this is also not possible. So option number D is also discarded. So option number A is the correct answer. Let us go for the next one. During the fusion of an organic compound with sodium metal, nitrogen of the compound is converted into. So this we have seen in the synopsis in the Lessines test before forming the Lessines test. So if in the organic compound, okay, if it consists of nitrogen, okay, so if it reacts with the sodium, so what it forms? What it forms, students? When you have an organic compound and it is when it is fused with sodium, okay, and if the nitrogen is present, so what it is converted into? It is converted into what? In the organic compound, carbon is also there, right? So it is converted into NaCN, that is sodium cyanide. Option number C. It is option number C. Okay, so organic compound is nothing but your organic carbon is present. Yes, Tejashwini has answered. Very good. So in organic compound, carbon is present. So what is happening? Your sodium, which is reacting when you are fusing it with the sodium organic compound, you get sodium cyanide. Yes, very good. Fine. Let us go for the next one. The number of pi bonds and sigma bonds present in naphthalene are respectively. So, what is a sigma bond? What is a double bond? So, very important. So, before that, you need to know the naphthalene structure. What is naphthalene? This is benzene, right? This is benzene. One more ring fused. Then this is what? This is naphthalene. If one more ring is fused, then what it is? It is anthracene. Okay, it is anthracene. So, this is our naphthalene. Calculate the number of sigma bonds and number of pi bonds. Number of sigma bonds and number of pi bonds. Uh, Pi bonds are 1, 2, 3, 4 and 5. So these are the pi bonds. Okay, these are the pi bonds. So 5 pi bonds, right? Then what are the sigma bonds? Calculate the sigma bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Carbons. Don't forget the carbons. Sorry, hydrogens. Your hydrogens are also there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it is 19 sigma bonds. Understood? Understood? One more time, I'll repeat. So let me write the structure of naphthalene. Naphthalene are two benzene ring fused. Okay. What is pi bond? So these are the pi bonds 1, 2, 3, 4 and 5. So these are the 5 pi bonds. Okay. Now going for the sigma bonds. Going for the sigma bonds. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now here 11, 12, 13, 14, 15, 16, 17, 18, 19. So this is what? This is a hydrogens are there. So how many? It is 19 sigma bonds. So it is second one. B. What is your answer? Yes, very good. Hema has answered, Chaitra has answered, Tejaswini has answered. Very good. So, yes, option number B is the correct answer. Fine. Let us go for the next one. So, this is very important question. They will ask such questions. Okay. Fine. I have some more questions. Just a second. Okay. Let us start. Dhanashree has also answered. Very good. Okay. Let us continue. So, this is the question. Mesomeric effect involves delocalization of. Mesomeric effect involves delocalization of A. Protons, B. Sigma bonds, C. Pi bonds, and D. None of this. Yes. Mesomeric effect. What do you mean by mesomeric effect? What it involves? Tejaswini has answered as B. Dhanyashri has answered as C. So mesomeric effect is nothing but it refers to polarity. Okay, how is polarity produced? When you have a electronegative atom. Okay, when you have a electronegative atom, what it will do? It will tend to pull the electron towards itself. As a result, there will be partial negative charge on the chlorine and partial positive charge on the this what hydrogen. So this is polarity. So when mesomeric effect it shows what shows the polarity. Okay, how it is how this polarity is produced? It is produced in some molecules. Okay, how it is produced? By interaction with pi bonds. Okay, by interaction of pi bonds. Okay, or between pi bond and lone pairs. So it is between two pi bonds or between pi bond and one lone pair. So like this your this is formed. So how is the polarity obtained? Polarity is obtained by this what mesomeric effect in the molecule showing the polarity. How this polarity is obtained between the two pi bonds or between a pi bond and a one lone pair of electron. Okay, so it is option number C. Option number C. Yes, Muni and Hema has answered. Very good. Dhaneshri has answered. Very good. Okay, let us continue with the next question. In Jaldar's method, ammonia from 5 grams of food neutralizes 30 centimeter cube of zero point 0.1 normal acid. The percentage of nitrogen in the food is A 0.84, B 8.4, C 16.8, D 1.68. In Jaldar's method, how to calculate the amount of percentage of nitrogen? So you need to know the formula. The formula for Jaldal's method to calculate the a percentage of nitrogen is 1.4 into N1 into V divided by weight. Okay. So what is 1.4 into N1? What is the normality? Zero point 0.1. Okay. What is the volume? Volume is 30. Then what is the weight? It is 5 grams. Calculate the percentage. Calculate the percentage now. Tejaswini has answered as C. Yes, what answer you got? A. Yes, okay. Moni has got A. Others? So I have got, after calculating this, I have got 0.84%. 0.84%. Okay. So this is in Jaldal's method. Understood? Is it clear?
Yes, ma'am.
Okay. Let us go for the next one. Okay. Chaitra has also answered. Very good. Okay. Let us continue. 1.2 grams of organic compound on jaldalization liberates ammonia, which consumes 30 centimeter cube of 1 normal HCl. The percentage of nitrogen in the organic compound is, yes, same, same formula, percentage of nitrogen is equals to 1.4 into N1 into V divided by weight. Calculate 1.4 into what is normality 1 into weight, volume is 30 and weight is 1.2 grams. Calculate and see. Hima is answered as option B. Yes, very good. Uh, when you have answered 35, very good. Ammu, Chaitra, Dhanyashri, Moni, Shilpa, Hema. Yes, very, very good. Okay, yes, it is 35%. Okay, so after substituting, you get 35%. So please remember this. If they ask you about Jalda's method, you need to know this formula. Okay, 1.4 into N1. N1 is nothing but your normality. Okay, normality is 1. Then volume, which is 30 centimeter cube, and weight, weight of the organic compound is 1.2. Okay, let us go for the next one. An oxygen containing organic compound was found to be containing 52% of carbon, 52% carbon, 13% hydrogen. Okay, its vapor density is 23. The compound reacts with sodium metal to liberate hydrogen. A functional isomer of this compound is A. Ethanol, B. Ethanol, C. Methoxymethane, and D. Methoxyethane. So ethanol is a alcohol, ethanol is a aldehyde. This is a ether. This is also a ether. Tell me the answer. Okay. So here, ethanol is what? It is alcohol. Ethanol is aldehyde. This is a ether. Ethoxy ether is also a ethoxyethane is also a ether. So what they have asked. So you have to calculate what you have to calculate. So this is a, problem based on empirical formula and this molecular formula, right? So okay. So let us solve. So how do you so what is given? They have given that 20 52% what is formed? Carbon is formed. And 13% what is there? Hydrogen is there. 13% what is there? Hydrogen is there. Okay. So what about its density? So its density is 23, vapor density. Okay. So what is the functional isomer present? So which is that organic compound they have asked. So how to calculate the molecular mass? So molecular mass is equals to 2 into vapor density. Okay. Density is equals to mass into volume, right? Density is nothing but mass into volume. So mass is equals to, so 2 into vapor density. Okay. So what is the vapor density is 23. So what is the molecular mass? It is 46. Okay, it is 46. So let us find, so based on the this, okay, we know the how to find the n. Okay, we have to calculate the empirical formula first. So empirical formula, and then we have to calculate the number. So percentage, so how to calculate? So you, I hope you remember this. Okay, and then relative number of atoms. Okay, then will be your simplest ratio. Then you have to calculate the simplest ratio. Okay, so which are the it is carbon is present, hydrogen is present, and oxygen. So these are the elements which are present. So what is the percentage of carbon? It is 52%. Okay, what is the percentage of hydrogen? It is 13%. Okay, and what is the percentage of oxygen? It is not given, but you can find out so 52 plus 13 is equals to 5 and 6. So minus 100, so it will be 5, 35%. So it is 35%. Oxygen is 35%. Okay. Now what is the atomic mass of carbon? Is 12. Hydrogen is 1. Oxygen is 16. Now relative number of this can be calculated how? 52 by 12, 13 by 1, and 35 by 16. Calculate this. This will be 13. So 35 by 16, 16 1, so it will be 2.18. Okay, and 52 by this will be 12 ones are 12 fours are 4.8 and 3. So it will be 4.33. Okay, 4.33, 13 and 2.18. So next is 4 point, so which is the this, what you say, lesser, which is the less among this? It is 2.88, 2.18. So 4.33 divided by 2.18, 13 by 2.18, and 2.18 by 2.18. So which is the simplest ratio? So after calculating this, how much you're getting? 4. So this will be 1.9. Okay. This is 2 ones are 2, 6 are 12. So it will be approx 6. This will be 2 twos are. So this will be approx 2, and this will be 1. So calculate. So what is the empirical formula? What is the empirical formula? It is C2H6 and O. C2H6 and O. So calculate the empirical formula mass. Calculate the empirical formula mass. 12 into 2 plus 6 plus 16. How much it is? 24 plus 6. 24 plus 6. 24 plus 6 plus 16. Okay. 6, 7, 8, 9, 10. 16, 2, 3, 4. So it is 46. 46. Okay. Now we have to calculate N. N is equals to what? Empirical formula mass by molecular formula mass. What is empirical formula mass is 46. What is molecular formula mass? It is also 46. So it is 1. Okay. So what is the molecular formula? It is also C2H6O. So it is what? C6, C2H6O. Now, what is the second? So we have found out here. So the compound, whatever is there, it is reacting with sodium metal and it liberates hydrogen. Okay. So hydrogen, so this, okay, whenever you have alcohols, so alcohols, when they react with your metal, okay, it will liberate what? It will liberate the hydrogen. Okay, hydrogen gas. So, so it will be what? So, the what is the functional isomer? So ethanol. Okay, so it will be CH3, CH2OH. Calculate. So C2, H, H6 and O. So what is the functional isomer for your alcohol? It is your methoxymethane. Okay, it is CH3O CH3. So your this is methoxymethane. So functional isomer is what? It is in methoxymethane. So option number C. So this is based on what? This is based on the molecular formula, empirical formula. So you have to put the table, find out the simplest ratio, then find out the empirical formula. Then from that empirical formula, find out the empirical mass. Then we have the molecular mass. So subtract. That is the formula is there. N is equals to empirical formula mass divided by molecular formula mass. We got 1. So, second, this was question was given as what? It liberates the hydrogen gas, right? So, it is due to what? It is due to the presence of the alcohol. So, this alcohol, so, okay, so it is having what functional group? It is having a methoxymethane. So, it is option number C. Option number C. So, it is the functional group. Okay, let us go for the next one. The CH bond and CC bond in ethane are formed by what type of overlap? Ethane. What is ethane? So this is a ethane. Saturated compound is called as what? Ethane. That is C2H6. Right, C2H6. It is called as what? Ethane. Now here, what is this type of overlap between the CH bond and the CC bond? So what type of overlap is present? So between the CC, okay, between the CC, what is there? Between the C and C, it is the sp3. Okay, it is between the CC, it is the sp3 and sp3 hybridized overlap is taking place. And between the CH bond, okay, here in your hydrogen is S. Hydrogen does not have p orbital, it has only s orbital. So this is S and this is sp3. So S sp3. So which is the answer? It is option number A. So overlap between the CH is sp3s and between the CC is sp3 overlap is taking place. Okay. So this is the type of overlap present in the ethane. CH is your sp3H because hydrogen does not involve the p orbitals, only s orbitals are there. Okay, and carbon it is having sp3. All the sp3 orbitals are involved in the overlap. Okay, yes, option number A is the correct answer. Very good. Okay. Next question, IUPAC name. So if a compound is given, you have to give the IUPAC name of the following compound. IUPAC name of the following compound. Yes, tell me the IUPAC name. So now here two these are there. Okay, two functional groups are there. Now between the hydroxy and your this what carboxylic acid, your carboxylic acid should be calculated as the this what as a parent chain. Okay. Now calculate, take the longest parent chain including this. So I'll start from here. 1, 2, 3, 4, and 5. Okay. Now your OH group will be acting as what? It will be acting as a substituent. Okay. It will be acting as a substituent. Calculate now. So at 4 position, you have start with the substituent. So 4 hydroxy. Then at so this is hydroxy. H will come first. This will be methyl. So then will be a methyl group. So 4 hydroxy, 2 methyl, 4 hydroxy, 2 methyl. Then the number of carbon atoms are uh, pentane, right? Pentane, this is your carboxylic acid. So it is pentanoic acid. 4 hydroxy, 2 methyl, pentanoic acid. Option number B. Option number B. Are you getting the same? Option number B. Tejaswini has answered. Yes, option number B is the answer. Chaitra has answered. Okay. So it is option number B. Understood? So now here too, please study the IUPAC nomenclature properly. All the rules are given. So when you have more than that is your own, no, more than one functional group is present. That is your carboxylic acid and you have to see the priority list. Okay, so your carboxylic acid can be taken as a parent chain and your hydroxy will be taken as a substituent. Okay, considering this note, we have given the IUPAC name. So please study the IUPAC nomenclature, all the rules, very important, because this rules only further it will help you to give the nomenclature for all the organic compounds. Okay, fine. Let us go further. Which of the following compounds possesses the CH bond with the lowest bond dissociation energy? So here, the answer is, so which of the following compounds possesses the CH bond with lowest bond dissociation energy? What do you mean by bond dissociation energy? Bond dissociation energy means the bond can be easily broken. So the bond dissociation energy for which of the compound is lowest? They have asked. Benzene. Okay, first one is benzene. Then is 2,2-dimethyl propane. 2,2-dimethyl 2,2-dimethyl propane. Then toluene. Then is N-pentane. Then is N-pentane. Okay. So can you tell this? So for which? Now here the answer is C. Okay. Because this your toluene will form the stable carbocation. Carbocation formation takes place in your toluene. Okay. So bond dissociation energy will be less here. The bond dissociation energy will be less. So toluene is the answer. Okay. So bond dissociation energy is less in case of toluene. So it can be easily broken. So it is option number C. A miscible mixture of C6H6 plus CHCl3 can be separated by, miscible means soluble mixture of your C6H6 and CHCl3, that is your hexane and your chloroform. A miscible mixture of hexane and chloroform can be separated by A. Sublimation, B. Distillation, C. Filtration and D. Crystallization. How it can be separated? When you have a miscible mixture, okay, they are soluble mixture, but they will have different boiling point. Okay, they will have different boiling point. So at different boiling points, these two different solutions can be separated by distillation. So distillation is a method where liquids are separated based on the differences in their boiling point. Okay, miscible liquids is only separated based on their. Yes, Monisha has answered it correct. Very good. Okay, so distillation is the method where liquids are separated, miscible liquids. Okay, based on their differences in the boiling point. Yes, Tejaswini has also answered. Very good. Let us go for the next one. Identify the correct statement in the following. Identify the correct statement in the following. A. Dimethyl ether and ethanol are chain isomers. Dimethyl ether. Dimethyl ether and ethanol are chain isomers. Okay, which is correct, they have asked. Ethanoic acid and methyl methanoate are position isomers. Let me write ethanoic acid CH3COOH, and what is methyl methanoate? Methyl, so H, so this is your methyl methanoate, so this is a ester. So these are termed as position isomers. Then next is N-butane. N-butane means CH3, CH2, CH2 and CH3. N-butane and isobutane. So that is CH3, CH, CH3 and CH3. So these are termed as functional isomers. Functional isomers. Then next is what? Propane 1-all. So CH3, CH2, CH2OH. Okay, and propane 2-all. So CH3, CH OH and CH3. So these are termed as position isomers. Position isomers. Can anybody tell me chain isomers? Which of the following is correct? Position isomers means there should be change in position. Okay, but here you cannot see any change in the position. Okay, so CH3 COOH. So identify the correct. So there is no change in position of any isomer. Then functional isomer. This is not a functional isomer. This is there is no any functional group. Then your chain isomer. There is no any chain involved here. Okay, chain isomer. These are what? Here you can see uh, in this first option, what you can see, there is a difference in the functional group. These are esters. This is a ether and this is a alcohol. So this is an example of what? It is example of functional isomer and it is not a chain isomer. It is not a chain isomer. Here what you can see, here you can see this is a carboxylic acid and this is a ester. So this is a functional isomer. Again, this is also a functional isomer. Then here you can see the number of carbon atoms are same. This is not a functional isomer, but this is a chain isomer. This is a straight chain and this is in a branched form. So this is a chain isomer. So this is also wrong. Then last one you can see there is a what? What you can see there is a change in position. Right? This is a change in position. So this is a position isomer. So option number D. Yes, option number D is the correct answer. Yes, Tejaswini has answered, Hema has answered. Okay, very good. So yes, option number D is the correct answer. I hope it is clear. Yes, resonance effect is not seen in. Resonance effect is not seen in or not observed in. In what the resonance effect is not observed? So here there is a conjugated system. Okay. So here you can see, so here Cl minus, so here also it will undergo in this system. Option number D. Okay, in option number D, you cannot see resonance. Okay. Resonance is not possible. There is no conjugated dyne system. Okay. So option number D. Option number D is the answer. Yes, Tejaswini Dhanyashri has answered. Very good. Let us go for the next one. Which of the following is not a pair of functional isomer? Functional isomer. So you have to see that the molecular formula should be same. There should be only change in the functional group. This is alcohol. This is a ether. So this is a functional group, pair of this. Then CH3, CH2, NO2, CH2, NO. So this is a amine, and this is a nitroalkane, right? So this is also a functional group. So what is a functional group? They should have same molecular formula, but only different functional groups. Okay, different functional group that we are checking. Now here when we are checking the first one, this is a alcohol, this is a ether, this is a nitroalkane, this is a substituted NH2 CH2 carboxylic acid. Next one, this is a methanoic acid and this is your methanoate. Okay, just now we have seen this is a ester, this is also a pair of functional group. Then your this compound C2H5 O C2H5, this is a ether and C3H7OCH3. Okay, you can see they are having same functional group. Okay, they are having what you can see, they are both same functional group. Okay, there is no there is same functional group, right? So this is not a pair of functional group. Functional group means what? They should have same molecular formula but different functional group. This is a ether. This is also a ether. So option number D. Option number D is the answer. It is not a pair of functional group. Yes, Dhanyashri, Monisha, uh, and Tejaswini have answered it correct. Okay. Is it clear? Are these questions clear? Okay. So we have completed this chapter, organic basics of organic chemistry. Okay. So I have taken some 30 questions. Okay. Approx 30 questions we have solved. I hope your doubts are clear. Yes. Any doubts? So I have taken important questions from this chapter. Okay, what all are important concepts. So based on the important concepts, the questions are solved. Okay. Okay. Any doubts? Any doubts?
No,
So
ma'am.
okay. So in the next class, I'm going to start with the next chapter, that is hydrocarbons. Okay, I'm going to start with the next chapter, that is hydrocarbons. So please study and come. Okay, before the next class, please study and come about hydrocarbons. What are hydrocarbons? Hydrocarbons are what? They are the compounds containing hydrogen and carbon, right? Okay, so that we are going to study in the next class. So based on that particular chapter, we are going to discuss the questions. Fine. So, okay. So any doubts, if you have any doubts, you can ask me, or else I'm going to end the session here. Okay, fine.
Thank you, ma'am.
Thank
Yes.
you, ma'am.
Okay. Thank you. Okay. So bye dear students. We'll meet in the next week. Thank you.